All it does is the TI already has built-ins for all these distributions, for the more popular ones anyway. All I've done is I've put the commands the TI uses in common English. Because what's frustrating I find with the TI sometimes is it uses stat ease, like very statistical ease language, and that can be confusing if you're not a statistician. So fire up, hit your program button, PRGM. It's right under stat. You probably don't have all the crap I have in mine in yours, which is a good thing. You should have probably 5 things. Right, now you may have a couple others depending on if you had programs before you came in here. But I gave you guys 5 yesterday and today. Distdraw, disfill, normal sample size calc, and GOF. And all of that will make sense by the end of 244 if you take 244. If you don't take 244, 2 of those you'll never use. Maybe. That's fine too. The one I want to play with right now is the one called distfill. Distfill. So go ahead and grab that one. And then press enter to run it. And what it asks you is it asks for the smallest x and the largest x. What it's talking about when it says x is what? What is that x standing for? Exactly, it's your data column. Remember your data column from yesterday? We created 4 distributions. The day before we created even more. So what it's asking you to do is to place in this the starting and stopping values for your distributions. So for the chickens, it would be 0 for the number of girls. You could have no girls at all, up to 4 girls. Okay? So you could have at fewest 0 girls, up to 4. And then it pops you out over to this screen here. It gives you a choice here, and this is my beta release, so I'm not sure if I'm going to keep this for years to years. Most of the time when students use this, they use it because they're going for a binomial distribution. So let's go ahead and do a binomial distribution. So I just picked one, or enter, whatever you want to do. And then ask for the probability on any one given trial. So that's 0.9. That's where the 0.9 comes in. The 0.9 comes in because that's the chance on a pool that Max gets a girl. So 0.9, and then you press enter, and then it says done. Which I know it's kind of like, oh great, it's done. But it just did all the work we did in class automatically. So if you go now and look at stat edit, you'll see the distribution that we painstakingly handcrafted last time. Stat edit, and there it is. Minus the L3. The L3 is left over from another class. There's your distribution. And now you know all the chances of all the numbers of girls. This is the number I came up with when I told you guys the original story. When the guy said, well, there's a 90% chance of a girl. I said, well, that means there's a 1/3 chance I got a rooster. This was what amazed him. Now, he shouldn't have, because I can barely add. It's just that I knew the idea that it was binomial, and I knew that this was about 2/3. So if there's a 2/3 chance that they're all girls, that means there's a combined total of about a 1/3 chance that there's a boy in there somewhere. How many boys? Well, depends. 1 boy and 3 girls is going to happen about 30% of the time. 2 boys and 2 girls happens about 5% of the time. 1 girl and 3 boys happens very, very rarely. And all boys happens almost never at all. 1 in 10,000 trials. So, of those outcomes, which ones are pretty likely? All girls is definitely likely. What else? Would you term this as pretty likely?
Yeah.
I would. That's 3 in 10. That's pretty high. A 3 in 10 is kind of like the chance of you getting a cold during cold season. And that happens quite often, doesn't it? Roughly 3 in 10 years. Hence the definition of a probability of 30%.
For example, I grabbed out of 5 Brahmas, one was a boy, and I'm usually pretty good at sexting, but...
Now here we go. I love this. My next question was, what if your flock is bigger? Right? What if your flock is bigger? Let's rerun the distribution program again. Let's go with 5. Let's say we go and we got a flock of 5 instead of 4. Now I would never just go back and buy one bird and throw it in the mix because she'd probably get killed. But if I started with a flock of 5, let's go ahead and run the program again. Just press the, you have to run the whole thing again. Go back to program, distfill. So you're back to the beginning. And now, if we're going to buy 5 birds, it's just 0 to 5. Just 0 to 5. Okay? And then the same deal, binomial, 0.9. Get done, go look at it. Stat edit, and there they are. Look what happened. Look what happened. Some things look similar, but some things changed, correct? For example, is it harder or easier to get all boys now? It's got to be harder, doesn't it? Because every boy is only 10% likely. Now it's 1 in 100,000 versus 1 in 10,000 to get all boys. Is it harder or easier to get all girls?
Harder.
It's still harder. This went down, didn't it? It was at 65%, 66%. Now it's under 60%, which means it's getting harder and harder to get all girls. It's still the most common. It still happens 3 in 10 times, right? Or excuse me, 6 in 10 times, 60% of the time. But it's getting smaller. It's getting smaller as we go. Is that fair? You see what's going on there, friends? Good, good, good. Now there's a 33% chance that you're going to get a rooster with your 4 other girls. Now, that's what Elena said. She bought 5 and she got a rooster and 4 girls. Well, that's 1 in 3. That's your 1 in 3 chance. That's going to happen, right? But there's also about a 7% chance you're going to get 2 roosters in there and 3 girls. Now, these, again, are still pretty unlikely. Getting the majority boys and the minority girls is still pretty unlikely, but it's getting easier to get roosters. Right? Does that make sense? How many birds would you have to buy so that all girls isn't the most likely outcome anymore? Isn't the most likely. In other words, right now, all girls is the most likely outcome. If you had 6, would it be the most likely outcome? Let's find out. This still again. 0 to 6. Doesn't this beat doing it by hand? Holy hell yeah. Because you can do it by hand, right? 0.1, 0.1, 0.1, 0.9, 0.9, 0.9. You can do it all by hand, but who the hell would want to? Okay, still 0.9s. Okay, she's done. Okay, still the most likely. But it's going down, and this one's creeping up. This is creeping. So my question for you guys is right now, explore with the TIs. Figure out what the minimum number of girls is. Excuse me, what the minimum number of birds is that pushes the distribution so that this is no longer the most probable. It does flip over. It does flip over. You find how many birds you'd have to buy. So far, if we buy 6 birds, it's still most likely that we have all girls. At some point, you can buy enough birds so that it's not all girls is the most likely anymore. You mess around with it. Keep messing. Keep playing. Keep playing. I'll shut